What is OSI layer model? ISO developed OSI reference model that describes how information is transferred from one network component to another, from point when a user enters information using a keyboard and mouse to when that information is converted to electrical or light signals transferred along a piece of wire. The OSI reference model is the primary model for network communications. The early development of LANs, MANs, and WANs was confused in many ways. The early 1980s saw great increases in the number and sizes of networks, as companies realized that they could save money and gain productivity by using networking technology. They added networks and expanded existing networks as rapidly as new network technologies and products were introduced. To assist in this process, the OSI reference model separates the network communication process into 7 simple layers.
Reasons for a layered model. To reduce complexity, networks are organized as stack of layers, one below the other. Each layer performs a specific task. It provides services to an adjacent layer.
Layer 7, Application Layer. This is the layer at which communication partners are identified, network capacity is assessed, and that creates a thing to send or opens the thing received.
Layer 6, the presentation layer. This layer is usually part of an operating system and converts incoming and outgoing data from one presentation's format to another. For example, from clear text to encrypted text at one end and back to cleared text at the other.
Layer 5, the Session Layer. This layer sets up, coordinates, and terminates conversations. Services include authentication and reconnection after an interruption. On the Internet, Transmission Control Protocol or TCP and User Datagram Protocol or UDP provide these services for most applications.
Layer 4, the Transport Layer. This layer manages packetization of data, then the delivery of the packets, including checkings for errors in the data once it arrives. On the Internet, TCP and UDP provides these services for most applications as well.
Layer 3, the Network Layer. This layer handles the addressing and routing of the data. IP is the network layer for the Internet.
Layer 2, the Data Link Layer. This layer sets up links across the physical network, putting packets into network frames. This layer has 2 sublayers, the Logical Link Control Layer and the Media Access Control Layer. Ethernet is the main data link layer in use.
Layer 1, the Physical Layer. This layer conveys the bit stream through the network at the electrical, optical, or radio level. It provides the hardware means of sending and receiving data on a carrier network.
Analogy of encapsulation. A balikbayan box is sent from Canada to the Philippines. The items to be delivered, wrapped up, and sent to LBC. LBC put the balikbayan box inside the truck. The truck delivers the balikbayan box into the ship. The ship passes the balikbayan box into the truck. The truck delivers the box to the LBC. LBC delivers the balikbayan box to the receiver.
Compare and contrast TCP/IP and OSI models. Similarities. They share similar architecture. Both of the models share a similar architecture. This can be illustrated by the fact that both of them are constructed with layers. They share a common application layer. However, in practice, this layer includes different services depending upon each model. Both models have comparable transport and network layers. This can be illustrated by the fact that whatever functions are performed between the presentation and network layer of the OSI model, similar functions are performed at the transport layer of the TCP/IP model. Both models assume that packets are switched. Basically, this means that individual packets may take differing paths in order to reach the same destination.
Differences. TCP/IP protocols are considered to be standards around which the Internet has developed. The OSI model, however, is a generic protocol-independent standard. TCP/IP combines the presentation and session layer issues into its application layer. TCP/IP combines the OSI data link and physical layers into the network access layer. TCP/IP appears to be a more simpler model, and this is mainly due to the fact that it has fewer layers. TCP/IP is considered to be a more credible model. This is mainly due to the fact because TCP/IP protocols are the standards around which the Internet was developed. Therefore, it mainly gains creditability due to this reason. Whereas in contrast, networks are not usually built around the OSI model as it is merely used as a guidance tool. The OSI model consists of 7 architectural layers, whereas the TCP/IP only has 4 layers.
Advantages and disadvantages of TCP/IP model. Advantages. It can be used to establish, set up connection with different types of computers. It works independently of the operating system. It supports for a number of routing protocols. It enables the Internet working between the organizations. It has a scalable client-server architecture.
Disadvantages. It is complex to set up and manage. IPX is faster than TCP/IP model. The shallow overhead of TCP/IP is higher than IPX.
Advantages and disadvantages of OSI model. Advantages. It provides wide variety of choice. It does not depend or rely on a specific computer system. It interprets the product functionality at each stage. It encrypts the data for security purpose. It is easy to add multiple network models.
Disadvantages. Many applications do not require or need the data integrity, which is provided by OSI model. In order to fast setup, OSI requires agreement by which 3 parties, users, service provider, and complex. This model is not adapted at all to telecommunication applications on computer.